New machine learning model could help predict oxidation state of a compound. Another AI model created by the synthetic designers of École Polytechnique Fédérale de Lausanne, EPFL, can assist with assessing the oxidation condition of a compound, a property thought about so essential that numerous scientific experts banter it ought to be remembered for the occasional table. New machine learning model could help predict oxidation state of a compound. Scientists deciding on the oxidation conditions of metal natural structures. At 2016, 118 components are known, which are all sorted in the popular occasional table found in each homeroom and science lab. Each component in the intermittent table appears to be a 1-2-letter contraction, for instance, Al for aluminum, O for oxygen, along with its nuclear number, which shows the number of protons are there in the core of the component. The quantity of protons present is extraordinarily critical, as it likewise oversees the quantity of electrons that circle the core, which regularly makes the component what it is and gives it its substance properties. The nuclear number is the ID card of a component. The periodic table should include oxidation states. Compound designers at EPFL's School of Basic Sciences broke down another number that ought to be accounted for each component in the intermittent table: the oxidation condition of the component, additionally called oxidation number. The examination was distributed in the Nature Chemistry Diary. At the end of the day, the oxidation state demonstrates the quantity of electrons that should be acquired or lost by a particle to foster a compound security with another iota. In science, the oxidation state is constantly detailed in the substance name of a compound. Oxidation states assume a particularly significant part in the basics of science that some have contended that they ought to be addressed as the third component of the occasional table. Barend Smit, study lead and professor, EPFL. Fusing machine-to-machine communication to accomplish Lab 4.0. Utilizing trace solid-state electrodes for metal analysis, Part 1. The best model is chromium. In oxidation state 3, the human body. In oxidation state IV, it is very noxious. Complex materials complicate things. Nonetheless, regardless of that, interpreting the oxidation condition of a solitary component is simple. On account of mixtures made out of various components, things end up being troublesome. Smit said, for complex materials, it is by and by difficult to foresee the oxidation state from first standards. Truth be told, most quantum programs require the oxidation condition of the metal as information. However, the current headway in estimating oxidation states depends on something known as bond valence hypothesis, created in the mid-20th century, which assesses the oxidation condition of a compound contingent upon the distances between the molecules of its constituent components. Notwithstanding, this doesn't generally hold, especially in materials with precious stone constructions. It is notable that it's difficult the distance that is important, yet additionally the calculation of a metal complex. However, endeavors to consider this have not been effective, expressed Smit. A machine learning solution. As a feature of the investigation, the researchers could prepare an AI calculation to arrange a famous gathering of materials, the metal natural systems, by oxidation state. The scientists utilized the Cambridge Primary Dataset, an archive of gem structures in which the oxidation state is given for the sake of the materials. Smit expressed, the dataset is exceptionally chaotic, with numerous blunders and a combination of investigations, master surmises, and various varieties of the bond valence hypothesis are utilized to allocate oxidation states. We expect that science is self-adjusting. So while there are numerous mistakes on singular records, the local area overall will take care of business. We fundamentally made an AI model that has caught the aggregate information on the science local area. Our AI is just the TV game. Kevin Jablonka, PhD student in Smit's group, EPFL. Jablonka added, who wants to be a millionaire? If a scientific expert doesn't have a clue about the oxidation state, one of the helps is to request the crowd from science what they think the oxidation state ought to be. By transferring a precious stone design and our machine-learned model as the crowd of scientists that will mention to them what the most probable oxidation state is. The examination was monetarily upheld by the European Research Council, ERC, the Swiss National Science Foundation, SNSF, and NCCR Marvel.